Hello, my name is Brian, and today I'm going to present the topics of the competition 5 of the subject of thermodynamics. Okay, today I will explain the fundamental properties and laws that govern non-reactive mixtures. This knowledge is key for applications in chemical engineering, meteorology, and air conditioning. Let's start with how the composition of a mixture is described. The mole fraction represents the proportion of moles and each component with respect to the total. Similarly, mass fraction tells us what fraction of the total mass corresponds to each component. In both cases, the sum is always equal to 1. The next time is in gas mixture PVT behavior is described by 2K laws. Dalton states that the total pressure is the sum of the partial pressures of each gas. Amagat, on the other hand, says that the total volume is the sum of the partial volumes. Both laws assume ideal gases. Ideal gases follow the equation QV equals 9RT, PV equals 9RT, where there are no interactions between the molecules. However, in the real mixtures, factors such as molecular size and intermolecular forces cause them to deviate from ideal behavior, requiring correction such as the van der Waals equations. When we talk about mixtures of ideal gases and vapors, we are referring to systems where gas and vapor phases coexist without chemical interaction. In this case, the properties of the mixture depend on the partial pressures of each component. For vapors, a key factor is saturation pressure, which is directly related to temperature. Dry air is a theoretical mixture of gases such as nitrogen, oxygen, and argon, without water vapor. Atmospheric air, which we find in nature, contains water vapor and its amount varies depending on humidity and temperature. Specific humidity measures the amount of water vapor per unit mass of dry air, while relative humidity compares the amount of actual vapor that the air can hold at certain temperature. Both are crucial to understanding the condition of the air. The due temperature is the point where the air becomes saturated and water vapor begins to condense. This concept is vital to predict phenomena such as the formation of dew for GO. Dry bulbs is the temperature measured with a common thermometer. The wet bulbs measure temperature as water evaporates, making it an indicator to the moisture contained in the air. Enthalpy combines the sensibile and head of dry air with the latent head of water vapor. In the other hand, the specific volume indicates the space occupied by a unit of mass of dry air and vapor, a key value in air conditioning systems. Okay, that could be all. Thanks you very much for your attention. I hope you liked it. And it's all.